All right, so here's the number one. Find the absolute extrema. Extrema values on this interval. For f equal to 5x to the 4/3. And here's the interval. Okay. Let me read the question real quick, double check. Okay, so basically find the max and minimum if they exist is what we're doing. But we said if there was an interval that's closed, then there's a possibility that these endpoints are going to be minimums or maximums. So we got to test those two. And then we got to find the critical numbers. So first, find the criticals. So the derivative, set the derivative equal to 0, right? So that would be f prime would be 5 times 4/3 times x. 4/3 minus 1, that would be 1/3, right? So 20/3 x to the 1/3 equal to 0. When is that equal to 0?
Um, don't we think I'm thinking
There's only one way this could be 0, right? What x value makes this 0?
0?
Yeah, so you can
Oh,
try to solve it, but it's pretty clear if you think about it, right?
yeah.
Um, if I plug in 0, 0 times this is 0. I don't see any other any other way to make this 0. But of course, you can try to solve it. That's what you should do. But okay, so what we're gonna do is test x equal to negative 27, 0, and 8 by plugging them in into f of x. And just see what's the biggest and the smallest. Since it's closed, we don't have to do first derivative test or second derivative test. Just find the critical number and the endpoints. So the function at negative 27, the function at 0, the function at 8. Okay, so this is obviously 0. Cube root of negative 27 would be negative 3. Negative 3 times to the 4th power would be 81, right? Should be 405. Now double check. This should be 2 to the 4th times 5.
Yeah, it's 405.
Okay. So what is my maximum?
-27. At -27, 405.
Yeah. And minimum,
0.
yeah, 0, 0, right? So if you see that it's closed, that's all you have to do. So you'll have probably one of these. And then they'll, I think, begin to move on. Let me see. Look at the review again.
Is the minimum the smallest number?
Yeah, for this type of example, whatever gives you the smallest value is the minimum.
Oh, okay.
So we don't have to test increasing or decreasing. It's just do it. Just find them. Okay. Any other questions on number 1?
No, that was quick and clean.
Yeah, it's not too bad, right?
Right. It's only gonna get worse.
Bro. I think the last question sucks. I'm gonna finish. Okay. I think the last one or one of the last ones are the sketching. That just takes time. So let's get number 2. It's pretty much the same thing, as just that they use a trig function instead of power function.
That's
So on this
3.
one, oh, sorry, go ahead.
You said let's look at number 2, but you're doing number
No,
3.
we're skipping 2.
Oh, okay.
Skipping 2. Is this the same as 1? They just have a trig function. Hmm. Sorry, so feeling pretty sick right now. Forgive me if I'm a little slow. Turn on the critical points for the function. So f of x is equal to -6x over x plus 2. Okay. We're gonna do a quotient rule. I'm gonna go ahead and do it just for the practice and for the notes, I guess. So this will be the bottom times derivative of the top minus the top times derivative of the bottom square the bottom, right? All right. This will become -6. So I'm just gonna put it in front just because I like to. Minus, this would be 1, so it doesn't really make a difference now. Combine your like terms, multiply stuff out, you're gonna get -6x plus 12 plus 6x. The negative and negative. So these will be gone. Okay. That should be negative.
Yeah.
Can this ever be 0?
I don't think so. Does
No.
not look
Can
like it.
be. The bottom, the denominator can be if you plug in
Look-
-2.
Yeah, but denominator is can't be. So that means when denominator is not equal to 0, that means there is no critical number, right?
Yeah, there's no way that the derivative will be equal to 0. There's no x that exists. So this has no solution. So what does that mean? If you try to solve it, you're gonna find out can't.
So is there an option for does not exist?
I don't know. Let me see.
Could you repeat why there's no solution?
Yeah, there is no critical point. That would be answer B. So there is no x, right? There's no way that the bottom cannot be 0 because then we have a problem, right? And the top can never be 0 because there's no x there. So there's no way I can force this to be equal to 0. Like I can't solve this.
Oh, okay, gotcha.
Do you see it? Or
Yeah, I understand.
okay.
It said, I mean, when I took the review, it said the answer was, oh, no critical points.
Right.
That's right.
There are no critical points because there's no solution to the derivative equal to 0. Because f prime equal to 0 has no solution. If there could have, there's a possibility, right? Remember we said sometimes if the derivative is undefined somewhere, but the original isn't, that could be critical. But this has undefined at -2, right? The original. And so does the derivative, so it's not gonna happen. There's not much to do there, just can't solve it. That we showed it though, right? Okay, where were we? Number 4 is similar, so I'm gonna move on to something else. 5, 6. Where was I? So the mean value theorem, remember I told you I wasn't going to test you on it, but there's a one question on there. Just go ahead and skip it. And if you do it, then I'll probably just give you points. But either way, I'm just going to give everyone credit for the mean value theorem because we did not lecture on it. So it's not
Okay.
fair to test you on it.
Talking
Okay.
about question 5.
Yeah, don't. If you see question 5 on the exam, just skip it.
Okay.
Go to 6. Okay, so using the derivative. Of f of x given below, determine the intervals on which f of x is increasing or decreasing. So we're not finding max or min, but what would you use to find those intervals?
Find the critical
The
number
first
equal
bit.
to 0.
Yeah, we need the critical numbers, right? And once we have them, what do we do?
Test the points.
Yeah, just test around them, right? Because we know that it'll be if the derivative is negative, then it's decreasing up until the next critical point. So first, let's find them. First, find the critical points. So set this guy to 0. So that means that this is equal to 0 and this can be set to 0. So the only solution for that is 0. And this will be 6, right? Okay. So let's test around it. Second, use the first derivative test. That's what we're supposed to do. To test around the critical values. Let's pick -1, I guess. Doesn't really matter. So that would be -1 to the 1/3 times -1 minus 6. So it'd be -1 times -7, right? So this is plus. Okay, let's test 1, I guess. One, plug in 1. We get this here, so that's 1 times -5, right? Okay. Now let's plug in anything above 6. That'll be 7 to the 1/3 times. Actually, you know what? 8 would be better because that has a cube root. Or you can use your calculator, doesn't matter. Uh, 8 minus 6. So cube root of 8 is a 2. 8 minus 6 is 2. So that's positive. Okay. So where are we increasing?
We are increasing at
Negative infinity and 0. Between negative infinity and 0.
Yeah, -infinity all the way up until 0, and then we change, right? Start to decrease. Where else are we increasing? We had 2 sections, right? So
From 6 all the way until forevermore.
yeah, there we go. Just make sure you use a union. And we're decreasing just in the middle, right? Yeah, that'll be it.
right. Just decreasing in the middle.
So any questions on the first derivative test? Because that's basically all this was. Because they gave you the derivative. We found the critical numbers like always. I'm hoping at this point that you're pretty good at finding criticals, but
Yeah.
if not, still got time. Any issues anywhere on this problem?
I'm pretty good at finding
I have a
criticals.
question on how you chose your numbers.
So you can choose any number below, above, below, and in between. But I chose -1 because I knew the cube root of -1 is easy. Same with 1. And then I decided to use 8 at the last minute because I knew cube root of 8 is 2. So basically, right, raises to the, well, actually, we could use the cube root, I think. Let me see. Right, cube root of 8 is 2. So that's why I chose 8. And then I knew 1 would give me a 1. And I knew -1 would be -1. This is the same as a 1/3 power, correct?
Yes.
So you could have chosen anything. You just would have to. I chose these, so I wouldn't have to use a calculator.
Okay.
Could have chosen anything you wanted and just punched them in. Doesn't matter. What
So how
matters
many-
is it positive or negative.
So we need to choose 3 numbers to figure out this, or how many numbers do we need to choose?
Yeah, if you have two critical numbers, then you got to test. So I guess think of it this way. Whenever you arrive at a critical number, then it might change from increasing to decreasing. It's not guaranteed, but it might. So, but everything beforehand will be consistent. So I test below. So now I know from -infinity up until 0, we're increasing because the first derivative told me so. It was positive. So I just need to test in between and after critical points. So before, in between, after.
Oh, okay.
So since I had 2 critical points, I needed to test 3 spots. So it depends on the critical points, how many you got. But if you remember, test between and after, it'll be good.
Is problem 7 similar?
Problem 7 looks like they want us to use a second derivative test. So as soon as you see talk about concave down, they're talking about second derivative. Okay, well, let's just go ahead and do it. You guys cool on 6, right?
Yes, sir.
Okay, so let me know. At any point, you can always go back. No worries. It's not a big deal. Determine the open intervals on which the graph is concave down. All right. Trying to figure out. Well, I don't know. I'll figure out the easiest way to do this derivative because I hate quotient rule, but sometimes you got to do it. But I'm thinking maybe we can be clever. You don't have to do it this way. You could do quotient if you want, but do you agree that these are equal?
Yes, sir.
Yes.
So do you see that I could just do a chain rule instead of doing quotient? To bring down the -1, subtract 1, and then times the derivative of the inside. I feel like that's easier. But I don't know if you disagree, you could do it a different way. As long as your math is legit, I don't really care how you do it. Okay, so that's derivative. The 2x times, what's 2 times 28? 56, is that right? Yeah, pretty sure. Now I'm going to bring this back down and we're done. Now at this point, I could do the same thing again, but it's not going to be much easier because now I have an x, right? So if I were to do the same technique here, to avoid the quotient, I would end up doing a product rule with a chain, which I don't think is easier. So this time, let's go ahead and do quotient. Again, you could do quotient twice if you wanted to. Doesn't matter. Doesn't matter. Okay. So derivative of the top times the bottom minus the derivative of the bottom minus the top. Where the bottom? G square square, you get fourth, right? Okay.
Right.
So now let's finish this up. So that'll be negative 56 times x squared plus 3 squared. Derivative of this will be a chain. So that will be 2 times x squared plus 3 minus 1, so end up at a 1 times the derivative of the inside. I'll do that in the next step, just to show more work. This is down here still. All right, this is about done. I'm going to remove the 1 because it might be confusing. Okay. Okay. Hmm. We could factor, I'm trying to make this look pretty before we set it to 0. Could factor these two, right? And a 56.
Right.
So negative 56 factor one of these as well. And you'll be left with x squared plus 3. This will be minus, one of the minus will be factored, but you still got one left. So it'll be negative 2 times 2x. So minus sorry, I lost my train of thought. Yeah, 2 times 2. So that'll be negative 4x times that 56, which is now positive. Minus space. I'm thinking the hardest thing about this question is the derivative, not the actual question.
I have a question.
Mm-hmm.
Is it 56 or 56x?
Oh, actually, 56 is gone. It should just be an x, right?
Okay.
Because I factored negative 56 from both. So one negative should be gone. Negative 56 should be gone, but this negative times 2 is still there. So this is really just x squared. Okay. Any questions so far? I mean, we're just doing the derivative or second derivative. I'm gonna continue on the next page.
No
Uh,
question.
Proceed.
All right. Okay. X squared plus 3 minus 4x squared. So x squared 3. This looks slightly prettier, right?
Yeah.
Okay. Hmm. I don't need brackets anymore. So that'll be negative 3x squared plus 3. All right. So set these to 0 and find your critical numbers. So there's double prime. Finally. All right. So set for the answer for concavity. So we need to test around the inflection point. In other words, set this to 0 and find it. The denominator doesn't matter. So let's just set the numerator equal to 0. So whatever makes this top part 0 will be good. Although, do you see any issues with that first factor?
First factor.
You mean x squared plus 3?
Yeah, this one right here.
Yeah, it's not
Yeah,
gonna.
I don't think that could be squared
could-
out. Because flip it over, you put the 3 on the other side, it becomes negative 3. You can't square out a negative.
Right. So there's no real solution. And even if there was, that would make the bottom 0, wouldn't it? Oh, wait a minute. You notice I forgot something?
What?
I should have just canceled this. Why? I don't need to do that. Right? There we go. So this is already gone. I just forgot. So that's not even a factor. It'll cancel one of the 4 down there. So all I got is a negative 56. So don't solve this. But even if you did, you can't. It doesn't make a difference, but you should have noticed that. So all we have is this. Okay. So divide by negative 56. That gets us here. Subtract the 3 over. That gets us here. Divide by negative 3. Square root both sides. So we have 2 inflection points. You okay with the algebra I skipped? Do you have any issues with how we got here? Or no?
No, not really any issues. I just need to write this down real quick.
I'll add the steps. Okay. So we're going to use a second derivative test to test around these values.
Scroll up. Can you scroll up real quick? Okay, scroll down. Hold on. I just need to see the top part.
Okay.
Wait. Up again. Just double checking.
Sure.
Okay, I got it. I got it.
Okay. Okay. So plug this in. Let's pick 0. It's easy. 2. And a -2. So f double prime at -2 would be -56 times -3 times negative. I confused myself. Those are the criticals. Or inflection points, sorry. -3. What was I doing? No, yeah, there it is. -2. What do I think that's going to be? The bottom will be positive, so cool. The top would be positive, negative, then negative again. Yeah, so it should be plus minus positive. Or you can plug it in your calculator and see exactly what it is, but it should be plus. F double prime at 0 is going to be running out of space. I'm going to skip some small things here. So this will be positive, that'll be negative. So negative. Okay. Double prime at 2. Looks like it should be. It'll be exactly the same. Okay. All we care about is the sign. So what does the second derivative test tell us? What were we doing again?
We were trying to find the open intervals in which the graph concaves down. So that means it concaves down at 0.
What's the interval?
The interval is that's I think negative infinity, or is it 0? Oh, no,
Well-
no, it's negative 1, 0.
Yeah, so everything in between the inflection points. So -1 to 1.
Okay.
So do we need to do the test for this question?
Yeah, we use the second derivative test to find out where it's concave down. Concave up from negative infinity to -1. Concave down from -1 to 1. Concave up from 1 to infinity. But they only asked about concave down, so this one. But we had to find that second derivative, which was annoying.
So I have a question.
Mm-hmm.
So the reason why there's a minus, the negative is because, no, since there's like a concave down, it's because there's a negative in the middle of the -1 and 1.
Yeah, so if you pick any number between the inflection points, if you plug it in and you get a positive, that means you're concave up in that section. If you get a negative, which I did here, you're going to be concave down here. If you're positive, you're concave up there.
Okay, thank you.
Okay, 8 is, I think, point of inflection. It's not too bad, I guess. Any questions on 7?
No.
No question.
All right, just let me know. That's what we're here for, is questions. Find the point of inflection. Of the graph. F of x equal to sine x on this interval, 0 to 2 pi. So to find inflection, what do we got to do?
Find the second derivative.
Yeah, we need the second derivative. So what's first derivative?
Cosine?
Cosine. What's the second?
Negative sign.
Negative sine. Okay. So set this to 0. So first step. Second step. There we go. To get negative sine x equal to 0. When is sine equal to 0? If you remember your pre-cal. When does that happen?
Is that one? No, that's I'm thinking about cosine. I'm sorry. I was going to say 1, but that's cosine.
No, it should be angles. What angles? With negative.
Oh, angles.
Pi.
Yeah, so the solution would be 0 and pi. So if you look at your unit circle, this is where sine is 0. If you don't have it memorized, just look at your circle. Okay.
Okay.
All right, so we have 2 points. Get a test around them. So now, test around x equals 0 and x equals pi. with the second derivative test. I'll pick pi over 2, I guess. 3 pi over 2. I can't go below 0, can I? Hmm.
You can't do negative pi over 2?
Well, it says to do it from 0 to 2 pi. So
Oh, okay.
let's just use these two. So f double prime at pi over 2. We got a negative sign at pi over 2, which would be -1. Oh, wait, hold on. I went too far. All they said was find the point of inflection. So that's this right here. Not bad. We don't have to find the concavity. You can, though. But we were done a while ago. So find the second derivative, set it to 0. That's it. Any questions on number 8?
No, that was pretty easy.
Yeah, I was making it harder than it should be. But I guess not reading the question carefully. Okay. Find the limit without using L'Hopital's. The limit as x goes to infinity. Of this guy here. Okay. I think we can explain ourselves. Since the denominator grows faster than the numerator, the limit is equal to 0. You could use some other techniques if you want, but if you just explain yourself, the degree of the bottom is 2, degree of the top is 1. If we let x go to infinity, the bottom will win out, and it'll make the whole thing 0. That makes sense?
So it's equals denominator grows faster than the numerator.
Yeah, just look at the degree. if the degree, you remember those rules I sent you with the asymptotes?
Yeah.
Basically, if the degree is bigger on bottom, the limit will be 0. If the degree is bigger on top, the limit will be infinity, because it'll just keep growing. If they're equal, that's when you have to do that, look at the leading coefficients.
So that's how we find it.
Yeah.
One more time, you explain it about the top one.
Yeah, so remember, x is going to infinity, right?
Correct.
So since this is a quadratic equation on the bottom, or quadratic function, this will grow much faster compared to a linear function. So as x gets infinitely large, the bottom will become infinite. But if the bottom gets to infinite, it's going to go to 0, right? Because the bigger the fraction on the bottom, the smaller it gets. So if the bottom is growing much faster, going to infinity, this whole thing will eventually be 0.
Understood. What about if it was the opposite, which is power, it was on numerator?
Oh, it's bigger on top?
Yes,
That would just become, it's just infinite. The limit would be infinity. Because it'll just keep growing, so it's just
it's gonna be infinite.
infinity.
Okay, so the answer is gonna be infinite if the power should be if it on the top.
Yeah.
Well, you need to find the negative or positive infinite on it, right?
It should be similar. You might just have a sign difference. But
Understood.
if it's going to negative infinity and it's bigger on top, it should be negative infinity here and 0 at the bottom. That wouldn't change.
Understood. Thank you.
Mhm. We're running out of time here. Let me see. Go ahead, do it. Number 10, the long one. So they want you to sketch this. So graph by hand. And find number 1, the intercepts. 2, asymptotes. 3, local extrema. 4, concavity. And 5, inflection point. So this one basically tests you on the entire chapter 4. We did one of these in class, you remember?
Yeah, we did.
Okay. Those are the intercepts first, I guess. So x-intercept. Remember we set this equal to 0 and solve. So we always have. This has a x in common, 2x squared minus 3x minus 12. But we have one intercept at 0, so it should be going through the center. So set this to 0. Set this to 0. Back to this guy. Negative 24. Negative 8 and no. Is that factor pretty? Let me see. Times 3 doesn't work. 2 times 12 doesn't work.
What about quadratic formula?
I was trying to avoid it, but I think you're right. Second. Yeah, they're not pretty. So I'm gonna skip the quadratic formula just because this question is long enough. So x will be approximately 3.31, and x would be approximately, when you do your quadratic formula and plug it into your calculator, you'll get negative 1.81. Okay, so there's my intercepts. For y-intercept, you let x be 0. And it looks like it's going to be the center part. So 0, 0. Okay, so there's the intercepts. Not very pretty, but oh well. Asymptotes. Do we have any? It's just a cubic function, right? So here's number 1. Number 2, no asymptote. Number 3, local extrema. So this is when we have to do derivative. So set y prime equal to 0. So that would be 6x squared minus 6x minus 12 equal to 0. Which would be this guy. I think this factors nicely, right? Yeah, still with me? Is that okay?
Yeah, we're still with you.
Okay. So we're gonna have to do the first derivative test. X equals to 2 and x equals to negative 1, right? So that would be your criticals from here. Just skips a
Okay.
small step. Trying to shorten this long question as much as I can. So let's choose 0, 3, and negative 2. Okay. So y prime at negative 2 would be 6 times -2 squared minus 6 times -2 minus 12. This would be 4 times 6 is 36, positive, positive. So that's plus, right?
Right.
Y prime at 0 would be 12, -12. Y prime at 3 that'll be larger, should be plus. So we have maximum, minimum, right?
Yes. All right, just writing this out.
Scoot your paper down if you can.
Yeah. Sorry about that. You'd have to plug it in to get the 7, but there it is. All right. So there's our extrema values. Now we need concavity. You guys cool on this first page?
Where do we get the 7 and -20 from?
You gotta plug it in. I skipped a step. So plug in -1 and 2 into y, and you'll get these.
Oh, okay.
It just
So
says that.
you use the original equation to find the minimum and the maximum, but use the derivative to determine the increase or the decrease of a graph of the graph, right?
Yeah. So the first derivative tells us where the max and min are at, but to find the actual y value, you gotta plug it into y, right? Because the function gives you points, the derivative gives you slopes. All right. Let's do concavity. Define y double prime. And set it to 0. So y double prime would be equal to, I don't know. 12x minus 6, right? Set it to 0. X would be equal to 1/2, right?
Right.
So plug in x equals to 1/2 into y to get the corresponding y value. So I'm going to skip that step as well because it's, I believe y'all can plug in numbers. So inflection at 1/2 comma -13/2. Oops. I guess I'm doing 4 and 5 at the same time. Oh well. So test around 1/2. I'll choose 0 and 1. So y double prime at 0 would be negative. Y double prime at 1 would be 6. So minus plus. So concavity, or we'll say concave up. Where are we concave up?
Concave up is at, I'd say +1.
Yeah, so after the 1/2 until infinity, right?
Right.
Concave down before the 1/2. All right. So we have everything now. So just sketch it. Okay. We have a point at 0, 0. Point at, was it 3 point something? I'm gonna graph it the way they did. Right. So we said 3.3. So that's about here somewhere. Negative 1.8. It's around here somewhere. We have a maximum where? About here, right?
Yeah. Did you move it down?
Yeah. 1 second. Minimum at 2 and 20. Again, this is just a rough sketch, so something like this. Yeah, it's a horrible. Yeah. Sorry about that. Missed the point completely. This one's a bit off. It just needs to go through here. Something like this. But it's not very pretty. So we have concave up after 1/2, so somewhere, so from here to here. Concave down below, after below 1/2. Your zeros are max and min, local max and min. Intercepts, y-intercept, x-intercept. So that's more than enough to have a really good idea what it looks like. And if you graph it with your calculator, you should get something like this. I think the answer is it C? A, B, C. Yeah.
Okay.
Anyway, does that make sense?
Yes.
All right. Any questions on that question, that problem?
No
No.
question.
All right. We move on to 11. That is not too bad. So they have a rectangular sheet. Of perimeter, 27 centimeters. Check the question. Perimeter sheet, over 27. And dimensions. X centimeter by Y centimeter. And it's to be rolled. To be rolled into a cylinder. What values of X and Y give the largest volume? Okay. So let's draw it out. I think they drew it on the question, I forget. The picture this rectangular sheet, dimensions X by Y. They're gonna roll it up and make a cylinder. See if I can draw a cylinder. Kind of. So do you agree that this, if I'm rolling it up, that this side would still be Y, right? The length for the height, I guess. Does that make sense?
Yes.
Yes.
Now X is gonna be rolled up, so what would X become? X is in there, but what is it?
Radius, I believe.
It's gonna be circumference. Okay. So, what's the volume of a of a cylinder?
The formula,
Mm-hmm. Do you remember?
um, pi r power 2, I believe, times
Pi r squared
times height.
times the height. Yeah, so just picture a bunch of circles stacked together. The stack is height. So there's my volume. Radius.
2
How's
pi
it called?
times r.
Yeah, I'll come back to that in a minute. If we think of it in terms of perimeter first, do you agree that the perimeter is going to be 2x plus 2y for the rectangle? Right?
Yes, which is half of the 27 centimeter.
And you agree that circumference is equal to 2 pi r? Let's get all our formulas together. So x is equals to circumference. So this is where the x comes from. So solve for radius. The radius would equal to x over 2 pi. Do you all agree?
Yeah.
So I'm trying to get everything in terms of one variable. Okay. So 27 centimeters is the perimeter, so we can set that equal to 2x plus 2y. If you solve for y, you're going to get 27 minus 2x over 2. So just plug that guy for the y. So we'll have a bunch of x's. Plug in this radius for the radius here. Now we have everything in terms of x. So that's the goal. So we'll get x over 2 pi squared times 27 minus 2x over 2. So I purposely use all the formulas that I could to simplify the question. Okay, so now we just have a basic formula in one variable. Okay. So one of these pi's will cancel in a second. This would be pi times x squared over 4 pi squared. Then I get rid of one of them. Multiply this out. We're going to get 27x squared minus 2x cubed over 8 pi. So there's v. So since we're trying to optimize, take your derivative. That will be 54x minus 6x squared over 8 pi. Set this to 0. And solve for x. All right. So 54x minus 6x squared equal to 0 implies that x is going to be 0 and 9. I'm going to skip a step here. I'm kind of low on time. Just solve for x here. Nothing crazy. So the question becomes, so that's the x dimension that will maximize your volume. One of these. Which one should we pick? Does it make sense to choose 0?
No, so it's not.
Or we have to have a dimension, right, for x. So we're gonna use, so this will be the x value that maximizes volume. If you want the y value, plug it in. So 27 minus 18 divided by 2. Here are the two dimensions we need. So the goal is to first write down the formulas that they're talking about. They mentioned perimeter, we got a rectangle, got a cylinder, we got circles. So write them all down just in case. And then try to get your formula into one dimension. Once you've done that, you just do a basic derivative, set it to 0, and you find your critical numbers. If it wasn't 0, you'd have to test them both, but it's clear that this is the best one. But anyway, that makes sense.
Yes.
Any questions on 11?
I have a question. How many question on the test?
Oh, I don't know, 10? I forget. I gotta check. But I think 2 of them you can. I'm gonna let you skip. So.
Okay, sounds good.
Right. Number 12 is Newton's method. To find the intersection of f of x and g of x. So to find intersections, all you gotta do is set them equal to each other. I think the book calls it h, but call it whatever you want. So what we're gonna do is use this formula once we have h. The function at xn over the derivative at xn. Okay. So subtract these functions. The h would be equal to f minus g, which is 2x plus 2 minus the square root thing. So apply your Newton's method on this. Because when you set these equal to each other and then subtract, so basically this is what you're doing. You're setting equal to 0, setting the difference equal to 0, because that's when they intersect. Okay. So two functions are equal when they intersect. So that means if I subtract it over and solve for x, then I can find all the intersecting points. Okay. But since this is a weird looking function, we're going to do the Newton's method. Okay. So to find. Okay, so the derivative will be 2 minus 1/2 times x plus 6 to the negative half. So let x0, I think x0 is supposed to be 3. So x0 plus 1, which is the next point, will be equal to x 0 minus the function at x0 over the derivative at x0, which would be 3 minus, I should use h technically. So that would be 2 times 3 plus 2 minus the square root of 3 plus 6 divided by the derivative at that same number. All right, so to save time, this will be punched into your calculator and you're going to get 3 over 11, which is approximately 0.2727. So that's x1. Then you would do it again. So x1 plus 1 is equal to x1 minus h at x1 over the derivative at x1. So that would be 3/11, which is that 0.27 nonsense. Minus all this stuff. Let's plug it all in. Plug it all in. Anyway, it's made basically a calculator question, right? So you will eventually end up with 0.25. So this would be the point of intersection by doing 2 iterations of Newton's method. So all we're doing is they're giving us a starting point. You plug it in to find the next one. So you get x0, you find x1. Here's x1. Use that x1, plug it in to get x2. And that's this right here. So the last question is another one I want you to skip. So don't worry about 13. So anything about linear approximation or mean value theorem, don't worry about it. Okay.
Okay.
So those would be your, basically curves or tests automatically. So just focus on everything else. Do you have any questions on this review?
No, I think this will really help us.
Yeah, I think so too. Okay. We're pretty much out of time. Maybe Thursday we'll have a chill day. Because this one was was a lot.
Yeah, I know.
Okay. Yeah, Thursday we'll probably start chapter 5. It should be pretty short.
Okay.
Just do like one simple section or something. Okay.
All right.
Let me take roll and then we can call it a night.